The title that we choose is Application of Differentiation. Before we go through the question, we need to know what is the meaning of differentiation first. Differentiation in mathematics is a process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical techniques of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation, and a knowledge of how to manipulate functions. There are various applications of derivative, not only in maths and real life, but also in other fields like science, engineering, physics, and so on. Application in mathematics such as rate of change of a quantity, tangent and normal to a curve, minimum and maximum values, Newton's method, linear approximations, and more. Next is application of derivative in real life. For example, to calculate the profit and loss in business using graph, to check the temperature variation, to determine the speed or distance covered, such as miles per hour, kilometer per hour. Derivative also used to derive many equations in physics. That's why we need to learn this topic. The techniques of differentiation consist of the first principle, also known as definition of derivative, constant rule, product rule, sums and difference rule, quotient rule, higher derivative, derivative of trigonometric function, derivative of exponential functions, and more.
Thank you, Tifa, for the introduction. So I'm going to continue with the problem statement. So this is the problem. Two people are 50 feet apart. One of them starts walking towards north at a rate so that the angle shown in the diagram is changing at a rate constant of 0.01 radian per minute. At what rate is distance between the two people changing when theta equals to 0.5 radians? So as we can see on the left side, there's a diagram to show how the situation is working. So there's the moving person and the stationary person, and the x and theta is the manipulated variables, and the 50 feet is the initial distance between the moving person and the stationary person. So that's all for me. We'll pass up to the next presenter. Thank you.
This example is not as tricky as it might at first appear. Let's call the distance between them at any point in time x as noted above. We can then relate all the known quantities by one of the two trigonometry formula. Cos theta equals to 50 over x and secant theta equals to x over 50. We want to find dx over dt, and we could find x if we wanted to at that point in question using cos sign, since we also know the angle at that point in time. However, if we use the second formula, we won't need to know x, as you'll see. So let's differentiate that formula, which would be secant theta times tan theta times d theta over dt equals to dx over dt divided by 50. As noted, there are no dx over dt in this formula. We want to determine dx over dt, and we know that theta equals to 0.5 and d theta over dt equals to 0.01. So just plug in and solve, which would be dx over dt equals to 50 times 0.01 second times 0.5 times 10 0.5. Hence, the answer would be 0.311254 feet over minutes.
In conclusion, we use the derivative to determine the maximum and minimum values of particular functions, such as cost, strength, amount of material used in a building, profit and loss. Derivatives are met in many engineering and science problems, especially when modeling the behavior of moving objects. There are many uses of differentiation that we can apply, such as it is used in history for predicting the life of a stone. It is mainly used in daily by pilots to measure the pressure in the air. It's also used in many subjects like physics, chemistry, and economics. It is used to solve problems including limits. And lastly, it is used to find local maxima and local minima. Last but not least, I would like to express my special thanks of gratitude to my teacher, Dr. Lau Si Ho, who gave me the golden opportunity to do this wonderful project on the topic differentiation, which also helps me to know about so many things. I am really thankful to him. Secondly, I would like also to thank my parents and friends who helped me a lot in finalizing this project within the limited time frame.